Thank you very much, Matt, and thanks, Jim, for the invitation to this great event here. Can you imagine what the world's going to look like in the next 50 years? You know, we're moving at such a fast rate of technological evolution that in 10 years, 60 to 70% of the jobs do not exist today. I always tell people this is actually going to be the decade of the science fiction. This is going to be finally, we're going to start seeing emerging flying cars. We're going to see autonomous cars. We're going to see things, technological evolutions that we haven't seen in our lives. So this finally is the decade when things are going to start moving forward as we expected growing up. So just to give you an idea also about the evolution of computational capabilities. Look, for example, at the transistors, the integrated circuits, when they were invented in the 50s. We could put 2 transistors on each integrated chip. With today's technology, we can put up to 20 billion transistors in one chip. Can you imagine that number? The issue now is we're getting so small, the distance between the transistors is so small, we're reaching at the atomic level. So we're reaching the limit of that. So we're looking into maybe architectures that involve 3-dimensional. We're looking into different architecture. But I think something's going to take it over from here is going to be quantum computers. Quantum computers on today's state, which is, I consider basic compared to what the capability and the potential that we'll have in the future. In certain cases, they can run analysis and solving issues at 100 million times faster than the fastest computer we have today. And so just move forward in the future until it gets an idea of what's happening. The robotic market as well is a very important market. It's expected to have about 70 billion in worth by about 5 years from now. But the challenge with that as well, we expect about 50 million jobs to be lost just in the US because of automation from robotic issues. Now, that is not a new discussion. We've had discussion at the beginning of the Industrial Revolution. People discussed about these aspects of losing jobs. People were nervous, and at the end, Industrial Revolution actually was an inspiration, and it was actually a tool for creating substantially better jobs, made actually jobs easier on people. The only challenge we have right now in this time is we're no longer competing on manual labor. We're competing on intellect. For the first time in history, we're going to be competing on intellectual capability jobs. So we're competing with all aspects of our jobs. And that's actually the key component is going to be artificial intelligence. If you look at any job right now, engineering, doctors, medical, finance, lawyers, see, for example, medical doctors and radiologists. With today's technology, which again I consider in the baby steps, it's still very early evolution of this technology, these systems can actually predict better outcomes from 9 to 10% in radiology reading of images. We're getting better results for people trading stocks. We're getting incredible value in engineering analysis. In lawyers, we're trying to actually put cases and find value in different things they're working on. So that is going to be impacting every single career, every single job we have today. And it's not going to be just from one day to another. That's it. The jobs are gone. So it's going to be an evolution. So initially, we're going to have actually very advanced intelligence systems going to be helping us hand in hand. And then the more we move forward and the more the technology matures and become much more pervasive, then that's when the challenges start happening. So it's going to be a balance between jobs created and jobs taken away. So that's kind of the thing we need to be looking at, is how much the delta, the difference between these two categories. So artificial intelligence, obviously, is nothing new. It's been in existence since the 50s. So why now? You know, in the last decade, we've been hearing a lot about artificial intelligence from so many sources. And I think it's due to 3 different things. Is the algorithms. So until recently, the algorithms we had were very basic, and they were actually erroneous in predicting the kind of outcomes we were looking for. But recently, in the last decade, we made incredible successes, and we created very, very complex algorithms that actually are getting us to the results we were looking for. But then the problem is, if you have very advanced algorithms with multi-layers and neural networks and all these complex analysis, you need very, very powerful computers, very powerful computational systems. And actually, the segment of the industry that was capable and credited for helping in that is the gaming industry. So with computers, for example, you have a CPU, you run an analysis, it finishes it, it goes to the next one, everything goes in series. And then you had quad core, or you had eight cores, so you can do maybe 4 or 8 calculations at the same time. But with the emergence of the GPUs, you can run actually 4,000 or 5,000 calculations at the same time. Also, the price of these GPUs became so cheap that any student, any research lab around the world actually can capitalize on the capabilities of this and produce analysis and data at scale that's actually much, much faster than anybody else. And then obviously, it's the big data. With that big data, we could have not done anything. So I see big data basically is the fuel that actually we're running this machine, making this machine run forward. So algorithms, computational powers, big data, finally are in stage, are in a position that enable us to make something helpful from the artificial intelligence. So artificial intelligence, there is a lot of ways that comes. There's multiple algorithms. There's supervised algorithms, for example. If you can give a system 1 million pictures between dogs and cats, it will say, okay, this is the classification. This number of pictures are cats. This number of pictures are dogs. It classify them into these categories. And then there is the supervised learning. But I think the unsupervised learning is the one that we're going to get a lot of value. Because what it does, it finds insights. It finds trends in ways that we cannot actually find. So instead of, for example, classifying the previous example I gave, cats and dogs, it will give you categorization saying, okay, for example, these animals are inside the house, these animals are outside, this is during the daytime, this is during the nighttime, this is in a cloudy weather. So it starts finding insights and start finding trends that we haven't thought about. So when you use this analysis and these techniques into different things in businesses, in medicine, in any aspect of our life, you'll be able to come up with new insights and trends we have never been thought about before by ourselves. Bias is a very important thing as well. So bias in algorithms and bias in data. So I've seen some studies from certain companies that were putting a nurse, for example, and trying to translate or put it into the context. The nurse was attributing to she, and the doctor was attributing it to he. So obviously there is a flaw in gender balance here. Same thing with the facial recognition techniques. There's significant imbalance between several segments and genders and ethnicities. They were not accurate. For example, there's also if you are outside the mainstream, you could be completely biased against these kind of things. There is an app in China that you can actually get a loan application, and within seconds you get a response whether you get approved or not. And what's interesting is this application uses about 5,000 parameters about you personally, which most of these companies don't release what these parameters are. But according to the company, they have about 8,000 parameters per user. And one of the parameters, interestingly, was the battery life. So it assesses the battery life of your phone, and if typically it runs on the low side, that's a negative connotation on you and might reject your phone because you're not considered a reliable person. But I personally, for example, I wait until the battery is almost finished to be able to charge it because that's good for the battery life. So if you don't fit in the mainstream, then you might be biased against all these emerging things, right? And you might fit, if you don't fit if you're like in the outskirts, you might be going through some bias, unfortunately, which is not needed. Regulations is something very, very essential. And for example, we've been having a lot of discussions recently with facial recognition. What's the implications? How much has to be regulated? How much not? The problem with regulation is it takes time, and we will never be able to catch up with the incredible fast evolution of technology. So we cannot be reactive. We have to be proactive. We have to be looking about what's happening in the next 5 years, what's happening in the next 10 years, and start coming up with laws that are actually a little bit flexible, a little bit predictive, and proactive as opposed to reactive to be able to do any meaningful things in regulation landscape. The emerging technologies right now, I consider them like Lego components. You can put them in so many different pieces and create so many actually capabilities and in ways we haven't seen before. And that by itself actually can be combined into creating substantial new value into the market, into technologies, into products, across all different industries. And just to give you an example, this is a company in Japan called Teleexistent. And they were able to use 5G technology, Internet of Things, robotics, virtual reality, artificial intelligence to create something called virtual mobility. So basically, you create an avatar of yourself, and that robot, for example, could be in a different country. And with extremely high speeds, with 5G, it's basically almost no latency, incredible high-definition virtual reality, and all these sensors. You put gloves, and you feel what the robot is feeling. You see a stereoscopic vision of what the robot is seeing. You can communicate with people. And you can see the robot's kind of very archaic, very basic. But just move forward 15, 20 years ago. It's almost going to be so advanced, like almost a human will be representing you in a different place, doing things, going in meetings for you, and changing completely the landscape. I'm just going to show you a quick video so you can see an idea what I'm talking about, this interesting product. can see, there is an infinite amount of possibilities you can create actually by putting all these emerging technologies together in ways that haven't been used before. But the value also from all these advanced systems is the collective learning. See, for example, us in the room here, if somebody reads a book, somebody learns something, it's just individualized. That person is only learning something. But when we're talking about advanced robots, when we're talking about driverless cars, whatever one car learns as it's driving, the parameters, defining the algorithms, the whole fleet of cars will learn. So imagine if you're having 1 million cars in the street, learning, gathering data, advancing. Every single car will learn the same thing. So exponential learning is going to go as well in a fast way, enabling them to become much more advanced. Now, we talked about the implication on jobs, implication of all these incredible technologies on the potential of displacing a lot of the economic and the jobs in the market. But let's look at the other side as well, is the population. So it's interesting that since the 1800, at the beginning of human evolution, hundreds of thousands of years ago, until the year 1800, the population of the Earth was less than 1 billion. And just the span of 200 years, we went to about 7.5 billion. And according to estimates of UN, we're going to reach 10 billion in 2050. I believe personally these numbers are erroneous. I think it's going to be much more than 10 billion by the year 2050, because these calculations did not take into consideration the 4 tenets I'm putting here: biotechnology, artificial intelligence, 3D printing, and nanorobots. Biotech, for example, we're doing incredible advances in CRISPR technologies, being able to modify T cells genetically and be able to target diseases would never thought was possible. Artificial intelligence, it will be able to predict also trends in disease before they even manifest in an actual ailment in a person. Recently, a couple of weeks ago, one of the artificial intelligence systems in MIT was able to create an antibiotics actually to fight bacteria that was resistant to antibiotics. So that by itself, today is about 700,000 people die every year from being, having bacteria that's resistant to antibiotics. And that number is supposed to increase up to 10 million people in about a decade or so. So imagine the incredible applicability of artificial intelligence in preventing and curing and finding trends and being able to save people's lives. 3D printing is having incredible effects now in being able to use your genetic composition specifically to create an organ that's actually based on your specific genomics composition. So there will be no rejection. There will be actually having access to people that will never get access to these kind of things. Nanobots, that's the next phase. I think it's between 15 to 20 years from now. We'll be actually able to supplement our immunity system by using these nanobots in the blood, being able to tackle diseases, improve our immunity system, and take us to a different level. They're having also incredible successes in finding the sources, the core foundation of what causes aging in humans. The telomeres, the DNA, what they keep getting shorter the more they regenerate. So if that is the case with all these kind of things, I think the lifespan will increase in the next 20 years to at least 120 years in terms of the average human lifespan. So you can tell, so we have a huge amount of population, and the jobs are going to be displaced, and less amount of people are needed to do these jobs. So that's going to be creating a challenge. So that means the economic models that we have today are not sustainable anymore. We need to look into new economic models that will actually be evolving with the emergence of these technology in every single aspect of our lives and be able to do something about them from today. Look at predictive analytics. Nowadays, predictive analytics, we used to do that. For example, if you were having an engine in an airplane, it tells you in about maybe 100 flights or 100,000 mission hours of running is going to create a mistake, it's going to fail. So basically what you do is you find when is the downtime and you do the replacements of these components so it doesn't affect the operational integrity of these things. But what's interesting now, we're doing predictive analytics about our behavior as well. Like social media, they collect, I've read researches up to 50,000 points per person. So imagine they can actually do predictive analytics and do things 100% tailored to that specific individual in terms of selling data, selling information, and so on. The problem is, we're starting to balance privacy and convenience. We talked about that yesterday at the table for dinner. And we talked about obviously we're getting incredible amount of convenience, like in levels we've never ever seen before. But the problem is there's no privacy anymore. So we have to balance these kind of things. And then, the increased productivity and inequality, when the Industrial Revolution came in again, the productivity increased substantially, but that didn't reflect on people's wages and the quality of life. And now with the emergence of advanced artificial intelligence, the productivity is going to shoot through the roof at a rate we've never seen before. So whatever you do in a week, you could probably do in a couple of hours. So what does that mean? But still people, I'll see the market still, people are going to be required to work 5 days a week, 8 hours a day. So the productivity is not being reflected in the segment of the population, right? So we need to make sure we understand that so we don't create a bigger gap of inequality because of these technological evolutions that are emerging into the market. Social fabric is being impacted substantially as well. Before people used to talk to each other in person, have conversations. Nowadays, actually, people still have conversation, but 50 to 60% of these conversations happen through electronic media, especially with the young generations. And it's fascinating that a lot of the people don't even feel comfortable anymore talking with each other in person. It's like all they do is knowing how to communicate with the electronic media. But the next phase actually is going to be the evolution of artificial intelligence systems. We'll be able to spend much more time talking to an artificial intelligence system that's actually very advanced. It knows more about you than you probably know about yourself. And imagine a system so capable, so powerful, so potent, and it has 100% compatibility instead of the personality with you. Imagine how much relationship and trust you'll be able to build with that. So how would that affect humanity? We're based, we have evolved to be in communities, to work together, to intermix, and that's completely going to start shifting away from that fundamental levels that we have from humanity. And the other challenge is, imagine if I can have access to hack these systems. I'll be able to convince the system to convince you who to vote for, what products to buy, So there is also implications and challenges we need to be aware of when we're working with this. So when I went to college, for example, the bachelor's was 5 years degree. So by the time you finished, the same material was actually there. Nothing has changed. And the same thing today, actually. A lot of fundamentals will never change. These are fundamentals of physics and technologies, but the majority of the things will be completely obsolete by the time you finish a 5-year degree. So the question is, or the challenge is, you'll be graduating from college, going to work for industry, not equipped with what's needed for the industry, right? So we need to have a loop, we need to have a bridge between academic institutions and actually industry and government and academia, all of them working together hand in hand to be able to keep modifying these academic curriculums. So when people actually are graduating and finishing and going into the work market, they're 100% equipped with what they need to do. And today this is not happening. So that's something we definitely need to push on to make it better happening. The lines are blurring between technologies. Before, technology intended for the car manufacturers was intended for that segment. Technology intended for the medical industry, it was actually intended for that industry. Technology intended for the education. So they were very segmented, very compartmentalized, right? Today, actually, the lines are completely becoming blurry. Look at artificial intelligence, how many industries it's impacting, medicine, finance, engineering, legal, transportation, manufacturing, on and on and on. Every single segment of our lives. Same thing with 3D printing, actually. 3D printing was initially intended to produce a component or a part, and that's nothing, that's almost a very small part of what 3D printers can do. Like I said, we can do, for example, organs, we can do in medicine, they can do construction, they can do actually clothing. So look at the clothing in terms of sustainability and technology as well. So clothing, when you create a shirt or a pant or something, I think the estimates I've seen 30 to 40% end up being in the trash when they cut these patterns, and there is a lot of trash that's generated. So from a sustainability level, it's actually very bad for the environment. But also, there's also things fail at the seams where things are stitched. It's not very comfortable sometimes because they are created in 2-dimensional when the movement typically are in 3-dimensional. So with the emergence of 3D printing, you can create clothing that are 3-dimensional, created from one single piece. There's zero waste, much more durable, much more effective and comfortable. And the cool thing about it actually is you can actually have eventually your own fashion designer. So using artificial intelligence, you'll be able to see what are the trends in the market, what is your personality traits, and being able to actually be your specific personal designer, designing clothes for you. So you have something, you have the capability to print it on the spot and being able to wear something different as long as you want. And the next evolution of clothing is actually electronics embedded in clothing. So you'll be able to do some health analysis, measuring a lot of aspects of your health, maybe for communication. So the clothing field by itself is becoming incredibly different than what we used to. And of course, for us, space exploration is paramount to use 3D printing. There's no way we can take all the spare parts with us. Just impossible from a weight perspective, from a logistics perspective. So we need to actually develop in situ resources and being able to build habitats with the resources we have in different planets and being able to do things without taking everything with us here. Same thing with driverless cars. It's going to be creating a lot of aspects in society and psychologically, connotations, and creating jobs and taking jobs. And for example, that industry is going to be creating less cars, because in the States, for example, we have per household about 3 cars per household. If we have driverless cars, most of the time, it's going to be not needing as many cars. So it's going to be using a little bit less cars. Insurance companies, if your car never going to be stolen, if actually the car never going to be into an accident, so what is the insurance model going to look like? The insurance is probably going to decline a little bit. Are we going to have hybrid models when people drive and the computer drives by itself? Who's going to be liable for the accident? When was driving who? So there is a lot of complexities and challenges, but at the same time, there's a lot of job creations. We're going to have actually need systems that for mobile offices, for entertainment, potentially creating food while you're driving and traveling for long distances. What's the impact on safety? From all these incredible radiation being emitted to be able to map the environment in front of you. Also, I've read something that says people at a certain age, when they stop driving, their cognitive ability declines substantially. Because driving a car is very challenging. You're always looking what's in front, what's ahead, what's speed limits, what the traffic lights. So when you deviate from that, it's an incredible amount of exercise mentally that you do every day. So when you take that away, they've noticed that incredible declines in cognitive ability. So we need to look into that as well. So our intuition about the future is linear. We have evolved as creatures. Everything was moving and changes were very minimum. We're growing crops, we're farmers, we're hunters, and the evolution was in terms of how we thought of intuitively. It moved very linearly. The problem is now we live in a non-linear evolving technological ecosystem, which we need to start learning and changing and forcing ourselves to think in a very different way. And the problem is when we strategize typically about the future, we tend to anchor ourselves with the limitations of today's technology. But today's technology could be 100% different in the next 5 years, right? So we have to have always futuristic look at what's happening, what's going on. And there is a lot of things you can do. It's very difficult, obviously, to predict what's happening exactly. But there are some tools and techniques you can use to maybe give you a little bit better prediction. This is, for example, a publication I just ran on Science Direct, machine learning. And you can tell how incredible changes exponentially in terms of the publication for that just little segment of machine learning. So the same thing could be done when you can search for number of patents. You can search for number of graduates for certain technological segments. What are the revenues starting to emerge, publications, investment, number of startups. And you don't have to wait so long, to go through the whole number of years, decades. You can do a micro-analysis in maybe 1 or 2 years and see what are the emerging trends happening there and being able to learn from that. Also, you'll be surprised at incredible solutions that exist somewhere and solve something you've been trying for years to solve. You spend millions of dollars, you spend so many resources in so long time, and that solution probably exists somewhere else. The problem when it's at the startup level, you might know what's existing. So it's really essential that you develop a relationship with incubators, with venture capitalists, with angel investors, because these are the people that know what's happening in the market. And if they know what's happening in the market, they can tell you what technology is evolving, and you can maybe actually look at it. And if you are visionary and you can actually connect the dots and put these kind of things in a context to help you strategically achieve your goals, and you connect them in the right way, you're absolutely going to be needing the competition. You cannot afford to be reactive. You have to be proactive from now on. Reactive is going to always leave you behind. You have to think very differently. So the thing is, what does that mean? Should we just throw away everything we've been doing and start completely with new technologies? And that's responsible as well. So that has to be a balance. So in my opinion, I think every organization should have a segment or a small department that actually all they do is actually look at futuristic technology, vet them, and you cannot, by the way, just copy and paste, because that will never work. You have to copy, adapt, change, modify, and then paste it according to specific needs in your industry. And by doing that, you start vetting new products, start looking into what's coming up, and after you vet them, you start introducing them, infusing them into your mainstream, and actually keep up ahead of the competition. Something very important is also diversity. I cannot, underemphasize the incredible importance of diversity. whether it's diversity of ideas, diversity of gender, diversity of thoughts, of products. Diversity is very, 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 very essential. And I love this quote from Einstein: when we think alike, no one thinks very much. And that's something that we struggle with in every single organization. We can have 20 engineers trying to solve a problem, and believe me, it's going to be running around the same kind of solution. But if you bring maybe 5 engineers, 5 business people, 5 lawyers, you have a young person, you have an old person, people from different geographical location, the amount of solution and ideas will come to you is incredibly beyond imagination. So it's very, very essential that we do that. Just to give you a quick example, so this is a company in the Netherlands that they produce electronic bikes. So the problem is with shipping, they were having about 75 to 80% of these bikes being returned to them because of damage. So of course, they came back to the engineers, and the engineers started thinking, okay, I'm going to create bigger screens. I'm going to bump up the metal on this side. I'm going to be able to invest in new equipment to be able to produce thicker material in this region. So they started talking about long time, I don't know how many, hundreds of thousands or millions of dollars in changing the designs. And then a guy that has nothing to do with anything, just was passing by, said, well, if we just print a copy or a picture of a TV in the box, that implies to the shipping people that they're handling something very fragile. So something simple like that, it reduced actually the return rates and the damage from 75% to less than 5%, and saved the company from going out of business to maintaining competitive advantage and solving everything else. So diversity is really, really, really essential. You need to be thinking different compared to the rest. The same thing with corporation. Look at Amazon, look at Google, all these corporations. They no longer just produce something. Amazon was an online supermarket, and now look what they do. They do retail, they do electronics, and do education. They're studios creating movies. They're into banking. The Amazon Web Services, which is incredible, one of the best services in the industry. So you need to diversify your portfolio as much as possible to remain competitive as well. And also, a lot of innovation comes from nature. It's incredible how you can think about all these ideas from so many different places. So this is a bridge in the Netherlands. They were tasked with creating illumination with sustainable lighting that doesn't cost a lot. And at the end, they investigated things from nature, and they found this butterfly specifically, the microstructure of the wing, the composition, if they actually were able to imitate it, it was creating lights and reflection exactly the same scale of actually having lights. So they were able to solve a problem with 100% sustainability by learning something from nature. And there's a whole field of that. It's called biomimicry. We can give you hundreds of examples of things and innovations that came just from nature. Acceptation is an incredible thing as well. Acceptation is basically a biological evolutional term that tells you that something was invented or evolved or used for one function, and then it was co-opted for completely something different. So we like to use that actually in a business context. So the birds, for example, in evolution, the birds were never, the feather were never intended for flying. They were intended for thermal regulation. And with evolution, time after time, they were actually enable birds to fly, but that wasn't the main intention from having the feathers. Just to give you, another 2 examples of acceptation, how using technology from one place or segments of this industries from different places to be able to solve a problem that you have. So this is an MRI in a kid's hospital, and they were having a lot of issues because these machines are kind of scary. Sometimes they make a lot of noise, and it's not a pleasant environment for kids. So the kids were being nervous, they were moving, and they were having to repeat the images again, extra radiation, the flows were getting longer. So again, the doctor started thinking, okay, let's give anesthesia to people, to kids, and being able to put them through these things. And then another person came in and said, let's actually make it a theme. Let's use the entertainment industry and move it into that medical field. So they did a theme where kids look at the movie, small movie, and the movie is basically going to go into an adventure, crossing the channel, and once you cross the channel, they're going to open a chest and get some prizes from there. And that by itself completely solved the issue, completely solved the problem. So you always have to think differently. And this is another example from a company that actually produces freeways. And they were promising that anybody that goes into freeway, they were able to maintain 100 kilometers per hour minimum. And the thing is, they started, and obviously it was very challenging for them to keep up these promises that they did. So they were not, a lot of people were getting into the freeways, and there's congestions, obviously, as expected. So what they did, they went into and started looking for models outside of their industry. So they looked at the aviation field. When you buy a ticket, for example, when there is a lot of seats available, the prices are very cheap. And the more you buy, the more expensive they get. So they adopted the same methodology and applied it to the freeway, where actually when there's not a lot of cars, the prices are cheap, But the more cars get in, the price is increasing. At the end, becomes almost prohibitively expensive to be able to get into the freeway. So that by getting an industry solution from different places, they were able to solve a problem that they had. Now, innovation, there's two phases. There is revolutionary innovation, and there is evolutionary innovation. And revolutionary is what we call moonshot also. Moonshot means that you're going to do something so difficult, so complex, that the challenges associated with that means that less than 3 to 4% will end up succeeding. But if you succeed, it will completely revolutionize your industry. And this is a good example for Apple, actually. So Apple, when they created their iPhone, they spent billions and billions of dollars in research and development. It was an extremely risky thing, given the amount of failures that happen when you're talking about revolutionary innovation. But look at Apple's right now. Like less than 9% of the products of the revenue come from selling computers. Over 60% come from the iPhone and the smart media. So imagine if they didn't invest and take the risk in doing that, where will Apple be today? It will be a completely different company, right? So sometimes you have to invest in revolutionary innovation to be able to do things. But innovation is a big word, right? I mean, you could do something as simple as the box, like we said. You can paint a picture of something. It doesn't cost you anything. Or it could be as complex and challenging, as expensive as creating a new technology like we talked about. People think, risk, man, I'm not comfortable taking risks. That's nice. Today, with the way things are changing, it's absolutely no question. Either you take risk or you're going to be completely marginalized and kept on the side. It's no longer something nice to have. It is a must. Every single person, every single industry have to be able to take risk, measured risk, obviously. You cannot just be irresponsible, but you have to take risk because sometimes doing nothing is actually the biggest risk, according to how things are moving with today's environment. Also, sometimes, I notice, executives come in and say, I want to be innovative. Our company is going to be doing innovative products. And then a lot of employees come in, start presenting ideas. Every single thing stops in the middle management. So to be able to solve this problem, you need to do two things. First of all, you need to put it in the performance evaluation of the middle management that they are actually required. They must do new creative, innovative things, and they will be actually graded and evaluated at the end of the year. But you have to also give them backup. If they fail, then we have the backup. Don't worry about it. Failure is embraced. Failure is encouraged. As long as you're doing the best, you're learning from it, we're adapting, we're making it better next time. So if you do it that way, people, they just don't like to take risks because they're afraid, if it fails, it's going to be negative impacted on them personally. So by doing this kind of thing, I think it's going to help substantially. And, you have to push the boundaries. So, for example, if you're working in the middle here, and this is the boundaries, the edge of the screen is the boundaries, you're not creating anything new. If you want to create something new, you have to push the boundaries that you have right now. And the problem is, the closer you get to the boundaries, the more antibodies you're going to get from your organization, the more issues you're going to have. But unfortunately, if you want to create something new, want to create some value, new categories, you have to push the boundaries beyond what's been pushed before. Especially at NASA, we hear this term, failure is not an option. Failure is not an option, obviously, when you have a rocket full of people going to space, or you're trying to bring people back, that is absolutely not an option. But leading to that, when you're doing research, when you're doing development, when you're learning new things, actually, we have a lot of things we learn from failure, and actually could be encouraged. Even in nature, I want to give you an example in nature, the monarch butterflies, actually. When they were at the larva stage, there happened some genetic mutation and error in the genetic composition that allowed them to eat poisonous weeds, actually. And because of that, when they evolved into butterflies, birds that were eating the butterflies were dying because of being poisonous. So with time, birds learned how to not to mess with the monarch butterflies. So an error, genetic mutation in the generations from one to another was actually credited with saving the whole species of these butterflies and moving forward. Also, when you create something, new product, you need to validate it early. Don't wait too much time until you find, I spent 2 years, I spent $10 million, and at the end it's a failure. And I love to use the Zappos example here. So Zappos is a shoe company that we're selling the shoes online. So before they invested in creating incredible warehouses and technologies and everything, what they did is they wanted to prove the concept and validate the core value proposition that they have, which was, are people going to sell or are people going to buy shoes online without actually having them in person? So what they did is they created a simple web page. They bought a lot of ads from Google, and they bought several hundred shoes. And they create an incredible value and business model where it's very easy for the customers to return the shoes back to the manufacturers or to the vendor in this case. So they did that, and they noticed actually people were buying shoes online. The model worked. Once they proved that, then they went and scaled up. They went into the conventional things, the distribution, the warehouses, the electronics, and then eventually, I think Amazon ended up buying them for a huge amount of money. But they proved the concept before they spent everything, and then once they prove the concept, they move to the next phase. I'm just going to give you a quick exercise, if you can bear with me here. It's like in each table, there's a bunch of pads. If you maybe can draw, what's your expectations for how the cars will be in the next 50 years, just as an example. Don't spend too much time, about maybe 30 seconds, if you can do that, please. Just kind of from your idea, what is the concept of a car going to look like in the next 50 years? Very, very fast, please. All right, now if you can share your design with your neighbor, please show them the design and show them what you have created. Okay, now I want you to answer a simple question, and honestly, you have to be honest when you answer this question. How many of you were embarrassed or actually, kind of shy to share the design with your neighbor? Yeah. So actually, by the way, this is the message I'm trying to say from this slide here. You won't believe how many people are afraid to share the new inventions, new ideas, because they are afraid of ridicule. They're shy. So Google actually is a master of that. They say you cannot force innovation, but you can create an environment in which innovation is allowed to exist. And that is the environment you need to do, actually. Nobody is ashamed or afraid or shy to share any innovation or any ideas. Maybe the first one is bad. Maybe the second one is bad. Maybe the third one is the best invention ever, or best idea ever, brought to that company. So you have to definitely pay attention to that, because that makes big, big difference in your organization. And then, today is like, industries are not just siloed. It's like, for example, if you look at the forest is not just individual trees. Forest is an ecosystem of trees. They communicate with each other. They can actually transmit nutrition. They can actually prevent each other. If there is infestation of species, they can actually warn each other about that. So it's an incredible ecosystem that works as a whole, as a single unit. It's not individual, as we think. It's just different trees. And the same thing, we should do the same thing with us, with industry. We should work with academia, with industry, with government, talk to different industries outside of your domain. It's very valuable to do that. So look, for example, why we're doing all these things, because we have a moon challenge of going to the moon in 2024 and actually establish a presence there, long-term sustainable presence. And without thinking differently, without actually engaging with different people across the board, across different industries, academia, government, international, it's going to be challenging dealing with all these kind of things. So the more you diversify and you work across the board, I think it's going to give you a very needed advantage. When astronauts go into space, they don't see borders, they don't see countries, they just see a planet. So what you need to do is actually pull yourself at a higher scale. Don't only immerse yourself in your industry, pull yourself up, see what's happening across the whole globe, across the whole industry. And if you do that, you'll be able to see things you haven't even knew that were happening. So it's really essential that you don't dig too much into your industry, pull yourself up and look at things from different ways. Sometimes I like to talk to schools, talk to kids, and I tell them about the incredible advances and how the changing landscape of the future, what they need to do. And I tell them there's no limitation. The limitations are self-imposed limitations that we put on ourselves. So don't ever put a limitation. You can actually achieve things you never thought it would be achievable. And definitely, the sky is no longer the limit. Obviously, people say the sky is the limit. The sky is no longer the limit. There's no limitations to the heights you can achieve. And the same thing applies to us, in industries, in academia, and government, and all across the board. I mean, there's no limitations. We can actually have tools and capabilities today we've never had in the history of humanity. We're taking things to a different scale. So in the last couple of days, I've been talking to different people here and listening to the products, listening to what they're doing. I was very, very impressed with the incredible products that are being produced here. So imagine if we put our collective intellect together from all of us across different industries to be able to produce, products and solve some of the world's, most challenging problems. I think the possibilities will be endless. Thank you very much.